So let's start with the 12 volt panel off the chassis or off the truck batteries. So what I have going on is everything is finally in and wired, the panel's live, and I have the feed from the truck coming in to a 200 amp breaker, and that seems like a lot for 12 volt DC, but each of the actuators had to have a 40 amp breaker. They really only pulled 20 amps, but they have like a 40 amp draw for 250 milliseconds. So they need a 40 amp breaker, otherwise you'll get nuisance tripping. So that's why the 200 amp main breaker, and my jacks are listed at 13.5 amps. And those are the ones that I picked up in the salvage yard 2 years ago. And exactly 2 years ago. And they're 20 years old, so we were kind of guessing on that. Once I put an amp meter on them and found out they were pulling 80 amps, I upgraded the breaker, or will upgrade the breaker. So there's the 12 volt. This is my small 12 volt panel that runs off the batteries of the truck, and the reason I did this panel and these guys off of this panel is because that panel and the stuff over there cannot push enough amperage because I have DC to DC converters, and that's because I have Tesla batteries pushing 48 volts. So that's why all of this runs off the truck batteries. And yeah, so I have the switches all in for each of the actuators, and what I've done is I've also installed a C-Level 2 tank monitoring system for the gray, black, fresh, and actually I have another one called Galley, but that's still fresh water. And I'm really happy with this thing because what it does is obviously it gives me my battery for the truck battery, so I can monitor that in here. Fresh is at 100% because I was filling the tanks to check my sensors. Gray and black are going to be the same because they're tied together right now. And the Galley is at 34%. So that C-Level monitor is awesome because it puts it in individual percentages instead of a third, a quarter, half, whatever. But I have bus bars for my actuators. I have a bus bar for my power for the actuators and my jack. I have a bus bar for my ground. My actuators actually have their own little bus bar for all the lines coming in and the control wires to each actuator, and each one, and the power as well, each one has their own little bus bar. And it's actually not a bus bar, it's a terminal strip, sorry. Each one has its own terminal strip because these are linked across. The bus bar is actually linked, everything is linked together. So there's the 12 volt. We'll go over the actuators and the C-Level and everything else and how that works in a different video. I just wanted to kind of update the wiring. I still have to tie up some loose ends, but for the most part, the 12 volt is pretty well done, like 98% done. I still have to change out my jack breaker, and I actually broke the back side of one of my 40 amp breakers, so I'm waiting for that to get here so I can replace that. But that's done. All the wiring's in. Everything's been run, super happy, and that's actually working. Now the big dog. So this is the 110, 12 volt, and 24 volt Blue Seas circuit breaker panel. And these are flush mount, on-off breakers. Obviously I have everything labeled, which is the same on the 12 volt. I have a 120 volt breaker, a 12 volt main breaker, and a 24 volt main breaker. And then all these guys are 12 volt. These guys are all 120, and then these three, room for one more, are my 24 volt breakers. So I have three separate systems going on in here, not too crazy. And they did a heck of a job putting this thing together and sizing the wires on the back side. Still have to tidy this up, but everything is in except for my exterior lights, door locks, and the bay lights. I have not wired those, but the wires are back here someplace. And you can see I actually have switches in. I have my 2 switches for my slide outs, which work great. I have a switch for my dump valve for the gray and black tanks. Those are all installed. And on the back side, you can see I have some of it labeled and kind of cleaned up a little bit. It looks like a jumbled mess because there's a lot of wire in there, man. God, there's a lot of wire. But that's the back side, and this will actually have a door on it, so I can access this in the future. The front side will also have a door, so I can access the panel. Both panels, the master and the sub panel, the 12 volt, are going to be recessed so that I can have these things covered going down the road or whatever. And when I have to access them, I just open the door. So I also have, as you know, my Oasis control panel. This is my control panel for the hydronic heating system that heats the domestic hot water, which, by the way, is endless. So with 150 gallons on board, I can take a shower for 2 hours before I ran out of water. Man, I would never run out of heat. It also preheats the motor, and vice versa. The motor will inherently, as it gets warm, heat the hot water tank, which is awesome in the wintertime. It also provides the warm air for the coach. I have 3 thermostats, 1 for the main area, 1 for the bathroom, specifically for the bathroom. So if you're taking a shower, you can turn it up to 85 if you want. And yeah, it'll actually get that warm. It's kind of nice. And then I have a third one that's going to be down in the bay down here. So there's the heating system. I have my color controller, and a lot of this stuff I'll go into detail in another video, specifically this guy, because there is a video or 2 worth of information on how to get around this thing and all the different stuff that it can show you. There's a spot for my solar coming in. There's a spot for shore power coming in. It'll show me my battery percentage. It'll show me the voltage. It shows me the draw. It shows me the direction, whether I'm charging or inverting or drawing power. This thing with the 712 BMV 712 Smart battery monitor is awesome. It has alarms. Highly, highly, highly recommend Victron. I can't say enough good things about their product. So there's the master electrical panel area. And here is the workhorse for this thing. It's the 2 Quattros. Again, Victron Energy. These are 48 volt, 5000 VA, basically watts. I believe those are interchangeable, and 70 amp inverters. And also, for another topic, is why I went with 48 volts versus 12 or even 24. And really it boils down to electrical safety, and we'll talk about that in detail later on as I start completing the rig. I also have my MPPT, again, Victron Energy, 150 watt, 45 amp solar controller. And this guy is awesome because it takes the 6 panels I have on the roof and sends all the power into those bad boys. I also have 2 DC to DC converters. I have a 48 volt to 12 volt, and it's only 30 amps. And this is why I put in that panel, because I am pulling so many amps using my actuators or using the pump for the jacks that I could not find a DC to DC converter that put out enough amperage to run that stuff. So that's why the decision was made to run those off the truck batteries. Second one down here, this is for my 24 volt loads, and it's pretty minimal. It's a 48 volt DC to 24 volt DC. It's only 12 amps because I'm only really running the fridge and the water pump, which is a total of like 6 amps or something, the 2 of them running together. This is part of it. This is my battery protect, so if my batteries get below a certain preset amount, it will actually shut off the DC to DC converters. And as far as protection goes, I have my main double 200 amp DC breakers. I also have a separate breaker for both the DC to DC converters, and then I have individual breakers like this guy for just this converter. I think I said inverter before, but it's converters. And then another breaker for this converter. I also have individual breakers for both solar arrays. So basically my solar is set up so that I have one array on the passenger side and one array on the driver's side, and these can actually shut off either side. And then just to be a little redundant, I can actually shut any power coming into the charge controller, and that's with that breaker. So all the breakers have been sized and obviously put in place for safety. And next on the list is the true mastermind behind nearly independent, self-sustaining viability on the road, and that's the 4 Tesla modules. And I've mentioned it before, these have just over 5 kilowatt hours of energy. So I have basically 20, I think it's 21, I can't remember the exact number, 21 kilowatt hours of energy, which is insane. The solar will put out just over 2,100 watts, and within a day, I can just about charge these back up. You'll see down here, again, I have my terminal strips for my power and for my actuator controls. And then for safety, I've also installed 2 200 amp isolation switches. And basically what that does is that takes my positive coming from each bank, and basically these front guys are a bank because they're 24 volts a piece. My back ones are also 24 volts a piece, so tied together they're 48 volts. So that kills the power running to the main breakers. And you might ask yourself, well, don't you have a main breaker here? Yes, I do, but that controls it from this point, from the breaker up. So that shuts everything off to the Victrons, so I can work on the Victrons. But what you don't see is that my DC loads are actually tied in on the back side of this. You can see those little red wires going down there. So they're tied into the lower side of the breaker. So even though these breakers may be shut off, my DC loads will still be live, and I'll still have 48 volts coming into the bottom of this. So these guys are for my ultimate safety and protection. So if I have to work on anything up here, I can isolate the Tesla batteries. So safety first. So that's about it. And I am really close on wiring. I still have to hook up a system to heat and cool the Tesla batteries as just an extra safety precaution. And I also have to hook into, where are those little guys? They're locked in there. These little wires right here are what feed the information to the BMS. So I have to hook a BMS and a thermistor, basically a thermostat sensor, into each of the Tesla modules. And what I have for that is, forgive the mess, but this is my Tesla battery monitoring system. This is a dilithium BMS from EV West. Those guys have been great as far as helping me kind of get this thing figured out, and it's really pretty straightforward. They give you a chart, they send you off instructions, and they're pretty explanatory as far as how to hook these up and how to set up alarms and whatever else for the batteries. I can set up a high voltage, a low voltage alarm. I can set up a high and low temperature alarm. I haven't dug into this real deeply yet because I have not figured out a great way to go from these little guys to the 6 or 8 pin connectors on the Tesla batteries. But this is one of the last big wiring projects I have left. Almost all the other wiring is wired in the coach. Like I said, all the wire is run, and I'm super happy that I'm going to start burying this and start putting the finishing touches on the inside of the coach. So there's a quick rundown of the current state of the wiring and the electrical and whatnot. I am going to go into great detail on a lot of these components. If you guys have any specific questions, shoot me a comment down below, and I will certainly get back to you and answer it the best I can. Like I said, there's going to be a lot of subjects on the electrical alone, because that's probably, actually it is, that was my biggest concern and still is my biggest safety concern on the build. It's funny, I've done all this structural work, and my most worrisome thing is problems that can be caused with improperly wiring things or improperly sizing things with the wiring. So until next week. What is next week? I have no idea what's going on next week. We'll have to look at the video and see what's up next. So until next time, Tube, as always, leave a comment about whatever and subscribe, and yeah. Don't forget, heading to Overland Expo West in the middle of May. Stay tuned for updates on that. I cannot wait to get this thing rolling across country and show it off at the expo.